far. I just graduated from school, now at university. I lecture at New Age Polytechnic in Kent. I'm a student of my PA is Girls High School. I teach computer science. It's my first time presenting at Python conference in Nigeria. What's the relevance of these studies? Let's just go straight. Free system can simply be referred to as goods. Transfer parcels from one point to the other. You buy stuff on Jumia and it is being delivered to you. You use postal services and all that. These are free and they need to be transported from one point to the other. Companies like Amazon of recent developed the technology of trying to make use of drones to deliver packages to their customers all over the world. So they need these such algorithms to help them distribute the parcels. Why do I have to use FLOYD-WARSHALL'S algorithm? There are several shortest path algorithms. FLOYD-WARSHALL'S help you to solve such algorithms such that it can not just transport, it cannot just find the shortest path from a location to several locations, but it can help find shortest path from several locations to several locations. So you can see the drone there. It's an Amazon drone and it's for delivering goods. Freight services is essential mode of transportation for low density goods. Goods that are not too big, goods that are not perishable, goods that are perishable in terms of saving time, and goods with short or low lifespan. Advantage is that it is fast. You want to get your stuff in less than 3 days. So that's the advantage of using aircraft. So what are the challenges? Aircraft travels from certain numbers of kilometers to deliver freight from one location to the other. High cost is incurred due to frequent stopovers. So we want to see how we can cut down these costs of traveling over long distance using aircraft. So the problem, however, is an optimization problem that cuts down distance traveled and minimize the numbers of stopover as to optimize time of delivery, as well as time-sensitive goods and minimize total cost. So here is a business concept. We are seeing how we can minimize costs, which is highly efficient. So what are our triggers? The main goal of this research work is to apply FLOYD-WARSHALL'S. So, like I said earlier, we have several shortest path algorithms like this algorithm, FLOYD, and all that. But I choose to use FLOYD-WARSHALL'S because it's not a single path. It's not a single source shortest path problem, but it's solved multiple shortest path problems. So we are going to implement it using Python and optimize it. Intelligent navigation systems such as GPS, every one of us knows GPS, and to guide cars along shortest routes and to minimize travel distance. All these are just very essential just to minimize costs. Now let me move straight to the shortest path problem. When we talk of shortest path problem, we are talking about graph problems. So, and if you want to think of graph, you just need to think of things. Just think of anything that's connected. So, those things, I call them vertices. And the connections are edges. So, we can simply define the shortest path problem as you are supposed to, the graph is supposed to have what? a graph G is supposed to have a vertex and an edge, that is E. And the weight of the function, that is, the edge implies the direction. So we must assume that G contains no circles or zero. I need to explain that. A point Ikeja to Ikeja, like you're supposed to, like yesterday, I missed my way. I was supposed to be at Ayeni, but I came here. And the vehicle had to, because I couldn't find my way easily, the vehicle had to take me around. So that is what we call edges that contain circles. From point A to point A should be 0. So a point leading from a very point to that same point, the weight should be 0. So if there is a road coming back to that same point, we are going to eliminate it because we are looking for shortest path. So like I said, FLOYD-WARSHAL'S is all peer shortest path problem. And is to find the length of the shortest path between all pairs of the vertices in the graph G. So the complexity of this algorithm, every algorithm has complexity. Complexity is quite big compared to its efficiency. Is an order of M3. That's quite large. So if you also want to think of a graph, you can think of a graph as, like I said earlier, things connected. You can computers connected by a network. That is a graph. And we want to save the cost of the wires of the connection. So you can find the shortest path from system A to system B. So you can think of people connected by maybe something like Facebook. People who are connected by relationship. And it's also a graph because they are connected in one way or the other. And that's why you have mutual friends and all that. Ancestries, websites connected together, that's also a graph. And you can think of a map. So representation of the graph. You can represent a graph using a normal graph or using an adjacent matrix. Now I decide to make use of an adjacent matrix because I will be able to code easily with that. Now, like I said, Abuja to Abuja, you can see 0. Lokoja to Lokoja is 0. Kano to Kano is 0. Calabar to Calabar is 0. And that's why Ekiti to Ekiti, state which I'm from, is 0. And that's why you can see the diagonal of 0. That's because you don't need, there is no cost traveling from a state to a state. You don't need to go around to other states and come back. That's what we call circles. So we remove all that. The essence of this algorithm is to help salesmen or companies like Amazon, like I said earlier, to deliver parcels from their office to all their customers without having to go to a customer twice or without crossing any vertex or edge twice, more than once. This is the algorithm. FLOYD-WARSHAL'S algorithm. It's quite simple. Just your numbers of rows, that is, and the vertices, and it just contains 3 for loop variable. Now the height, j, and the k. Now this is all just this main line. That is all the algorithm does. It finds the minimum comparing 2 paths. Then it selects the minimum and return the minimum. How it works? Consider a shortest path P from, let's say, Lagos to Ibadan, or let's say Lagos to Calabar. such that the intermediate vertices, that is the points in between Lagos to Calabar, are from I to K, from 1 to K. So the towns between Lagos to Calabar are K. So if the vertex K is not an intermediate vertex on the path P, then we make use of this. That is the distance between Lagos, which is I, and the subscript J, which is Calabar. Putting in consideration all the vertices, the number of vertices within Lagos and Calabar, then it's going to just do this. Subtract one vertex from the distance. That is where you are starting from. And find the shortest vertices. The one with the lowest number of vertices is returned as the shortest path. Now, if the vertex K is an intermediate vertex on path P, then it's going to do this. This is a bit complex. It's going to equate what we have just calculated above. It's just going to take the sum of the vertices, taking out your source, Lagos, that's K minus 1, and add it to that of Calabar, taking out the end point 1. Then it's going to calculate the number of vertices between. Then it's going to pick any of these. That is, if there's a lot number of vertices in between. Interestingly, in any case, the subpath contains mainly nodes from I to K minus 1. So if you have 10 vertices, it means you have 9. If you have 10 vertices in between, it means you have 9 vertices. So deduction, this is the algorithm. That's just the main line of the algorithm. I'm just trying to see. Now look at this. You want to travel from Lagos, from Abuja to Lagos, and you have to pass through Lokoja, Ekiti, and then Lagos. Why taking all these routes if you can pass through Abuja, Akure, then Lagos? So that is to say, you have more vertices here, and the other part, you have just one vertex in between. So let's quickly do some little mathematics. Now, let's take 1 to be Lagos, let's take 2 to be Orange, and let's say, and the 3 to be probably Benin. Now, if the cost to travel from 1 to 2, if the cost is 1, and the cost to travel from 2 vertex 2 to vertex 3, the cost is just 2. And the cost to travel from vertex 1 to 3 is just what? 7. Cost to travel back from 7 to 3 to 1 is 6. Now, that is why we have this first adjacent matrix. I told you I'm going to use adjacent matrix. So I'm using this little number of vertices to represent, I represent just this graph on this vertex, on this matrix. So the first column is column 1, the second column is column 2, column 3. So from 1 to 1 is 0. From 1 to column 2, from 1 to 2, the cost is 4. And from 1 to 7, from 1 to 3, the cost is 7. So just representing what is on the graph to converting it into an adjacent matrix. Now, you see just down the middle line downward, there's a sign here, infinite. That is from vertex 3 to 2. There is no path from vertex 3 to 2, but there is a path from vertex 2 to 3. This is because we are using a directed graph. You follow the president on Facebook does not mean the president will follow you. That is what is called directed graph. But you have a younger brother, he's your brother, and he will also say you are his brother. So it's bi-direction. So it's undirected. So the next one, this is the first time the algorithm is going to work. Now, if you check through, you see that the infinite has been reduced to 10 because the algorithm could help us find, because we must go to 2 from vertex 3, then we need to find a route. Then it goes first to 1 and goes to 2, from 1 to 2. So that is why we have 6 plus 4, and that is 10. I don't want to go us with all the calculations, I just want to show us a few of them. So the next one, yeah, you can see 10 is highlighted. Now the next one, any difference? Still same. Okay. The third row on vertex 3. The distance from 1 to 3 is what? 7 initially in the first line. But now you can see it has been reduced to what? To 6. So you can tell me what route it passed through to get 6. Nice, smart. So it's passed through from 1 to 2, then 2 to 3. So reducing the cost. Almost done. Now the last one. After going through everything, it's finally no changes is being made. Then it outputs this to us as our shortest path. It finds the shortest path not just from 1 to 2, but it finds the shortest path from 1 to 2 and 3, and from 2 to 1 and 3, and from 3 to 1 and 2. All you need is just frameworks like Flags, GUI. You can import Thinker, dilute my jam, and use. Basically, I just used Jupyter Notepad because it's easy to use for beginners. So you can run your code and see the results outside. Conclusion. This study will contribute greatly to the use of FLOYD services, development, planning. So you, Nigeria here, we keep focusing. We must have implemented some of this to find the shortest path from one location to the other. And also demonstrating how this application to all the great Pythonistas said. Yeah. Those are my reference. Thank you for listening. Any questions?